So the first part of urine formation is filtration, and it takes place in the renal corpuscle, which is this, and you can see that's blown up from that little part right there. And within the cup, or the Bowman's capsule is a cup-like sac that helps with this first part of urine formation, and you can see Bowman's capsule. It's this purple sac that surrounds those capillaries. And within the cup is the glomerulus, and it's a capillary bed of blood vessels, and you can see that inside there. You can see the red capsules. And the capillaries have blood that enter the kidney through the renal artery. And from what I can figure out, I believe this is the renal artery, because it says here that entering the kidney, the renal artery branches into smaller arteries and eventually into the afferent arteriole. And so if you follow it up, you see that afferent arteriole, so that is where the blood comes from. It goes through this artery and in to the renal corpuscle. And let's see. So as blood travels to these capillaries, some of the fluid or some plasma called filtrate, it spills out of the glomerulus, and it's collected by the cup-like Bowman's capsule. So it spills out of there, and this catches it. And this solution that spills out is what eventually becomes urine. And the actual spilling of it is what's called the filtration. And if a substance will be filtered, that's decided by two things. It's decided by the size of it and the charge of it. And so things that are filtered are water, glucose, sodium chloride, amino acids, small proteins, metabolites, and urea. And things that are not filtered are medium to large proteins, red and white blood cells, and platelets. And let's see what else. Here's my notes. So in order for substances to pass from the glomerulus to the Bowman's capsule and through the rest of the system, it has to cross the filtration barrier, and this has three obstacles. So the first one is the fenestrated endothelium of the glomerulus. Sorry, I really don't know how to say that. And then, so that's the first obstacle. The second one is the basement membrane of the endothelium. And the third obstacle is the visceral layers of the Bowman's capsule. So going back to the first one, fenestrated endothelium, there's two things that are responsible for the capillaries to filter the plasma this way. The first one is the glomerulus is made of special type of capillary called the fenestrated capillaries. And the walls contain fenestrae, which are windows or like pores in the capillary membrane. And the fenestra are about 70 nm, and blood is 7,000 nm. So blood does not fit through the fenestra. So that's why blood is not filtered into our urine. And that's why it's a really bad thing if you do see blood in your urine, because it's really not supposed to be there. And then the second thing is negatively charged glycoproteins. So there's small proteins, but they're the same size as the fenestra or as the pores. So they could be filtered, but what stops them from being filtered is that the negative charge. They're negatively charged, and so that's what stops them. So overall, the first filter, I guess, or the first obstacle, it prevents filtration of the blood cells and plasma proteins. So I guess that's what you need to take from that. And so the second obstacle, the basement membrane of the endothelium, it's a matrix of anchored negative charged proteins that act as a barrier to circulating negative charged proteins in the blood. And then the third obstacle is the visceral layer of Bowman's capsule. I'll move that up. And there's three parts to the Bowman. The first one is the parietal parietal layer. And this is just one layer of simple squamous epithelium. And the second one is the Bowman's space. And this space is what receives the filtrate. And then the third thing, or the third part, is the visceral layer. And this surrounds the glomerulus. And this visceral layer is made up of podocytes. And these are long finger-like processes that encircle the capillaries. And they come together forming like slits or gaps called filtration slits. And that's the third filter, is those filtration slits, depending on what can get through those or not.